Imagine imagine opening your department's monthly cloud compute invoice.
Mm.
You are fully expecting the routine budgeted charge.
Right, like maybe $5,000 for your standard server load.
Exactly. But instead, you are just staring down a staggering $63,000 bill.
Oh, wow. Yeah.
And as you scramble to audit the logs and figure out what broke, the sinking realization hits you. This entire financial hemorrhage happened simply because your team has been politely saying please and thank you to an enterprise AI.
Yeah, that is terrifying.
Right, and feeding it 50-page documents just to answer a one-sentence question.
It really is the ultimate wake-up call happening in boardrooms right now. I
Yeah.
mean, we have spent the last few years just completely intoxicated by the magic of what large language models can do.
Oh, absolutely. Writing code, drafting contracts.
Yeah, summarizing those chaotic hour-long meetings. But the honeymoon phase of wild, unconstrained AI experimentation, as well as violently colliding with the cold, unforgiving reality of AI economics.
Which is the exact mission for our deep dive today. We are going beyond the hype of the capabilities to really uncover this massive hidden financial sinkhole that is threatening enterprise AI.
It is a massive threat.
It is. And more importantly, we are going to tear down the specific hard-nosed engineering architectures required to fix it. We are drawing our roadmap today from an incredibly revealing analysis published by Jay Tanner back in March of 2026.
And we should establish right away that this analysis comes from AI Index and AIindex.com.au.
Yes.
Which is Australia's #1 source for AI trends and analysis. They sit at this incredibly valuable vantage point, monitoring the broader industry shifts.
Right.
And they have successfully captured the exact inflection point where companies are realizing that AI is not just a software deployment. It is a highly variable financial liability.
Okay, let's unpack this. The ultimate payoff for you listening today, whether you are, say, a technical lead trying to keep your department's budget afloat, or a business strategist trying to understand the actual unit economics of this stuff, is discovering how to take that staggering $63,000 monthly AI bill and fix it.
Yes, engineering it down.
Exactly.
Yeah.
Through pure engineering discipline, crush it down to just $7,500, and doing it without sacrificing a single drop of quality in your output.
That is the core promise we are exploring. Because the solution we are going to look at isn't about using AI less frequently.
Right. It's not about taking the toy away.
No, not at all. It is about restructuring the underlying architecture so you are using it with surgical precision. But to get there, we have to fundamentally change how we think about the product we're actually buying. We aren't buying software licenses anymore. We are buying tokens.
And most of our listeners probably know the basic definition of a token, roughly 4 characters of English text. It's the microscopic unit of trade. But what the source material makes just painfully clear is that the token itself isn't the problem. The problem is the two-way toll booth and how unpredictably those tokens scale in an enterprise environment.
What's fascinating here is how alien this pricing model is to traditional IT procurement.
Yeah.
I mean, if you provision a standard database or you buy a block of cloud storage, you negotiate a flat rate.
Or a tiered model, yeah.
Exactly, a highly predictable tiered model.
What?
You know what your terabyte costs. But an AI token is dynamic. You are paying a toll, so the input. So
Yeah.
every single character of the prompt, the hidden system instructions, the retrieved documents.
All of it.
All of it. And then you are paying a completely different and usually much higher toll for the output the model generates.
It's like jumping into a taxi cab, but instead of paying a flat rate for the physical miles you travel, the meter is wired to the actual conversation.
That is a great way to put it.
Yeah, you are paying a premium for every single word you say to the driver, and you are paying an even higher premium for every word the driver says back to you on the way to your destination.
That is a highly accurate visualization.
Yeah.
And the complexity deepens because the taxi fleet itself has radically different pricing structures.
Oh, right.
The source highlights the current landscape. You have models like GPT-4 Turbo, Claude 3 Opus, Gemini 1.5 Pro. These are the frontier models, the absolute supercomputers of the fleet.
The luxury black cars.
Exactly. And their token costs are heavily weighted based on their immense parameter size and reasoning capabilities. But teams are just treating them as interchangeable commodities.
So if I hand that luxury taxi driver a 500-page manuscript and say, read this entire book and then tell me if I should turn left or right at the next light, I am paying the conversational toll on all 500 pages just to get a one-word output.
You are. You really are. And this is where the concept of the context window becomes a financial trap, rather than a technical feature.
Interesting, because everyone talks about context windows as the holy grail right now.
They do. The industry has been celebrating these massive expanding context windows.
Yeah.
We now have models that can hold hundreds of thousands, even millions of tokens in their active memory for a single prompt.
Right.
And the engineering mindset has traditionally been, well, if the window's big enough to hold the entire code base or the entire legal repository, just throw it all in there to give the model maximum context.
Wait, let me push back on that for a second, because logically, doesn't more context lead to a better, more accurate answer?
You would think so.
Right. If I'm building a tool to query my company's internal data, why wouldn't I want to leverage that massive memory capacity?
Because of the nonlinear financial scaling. Yes, the model can actively process a massive context window, but you are billed for every single token in that window, every single time you hit send. If you have an application where a user asks a very simple question, and your architecture automatically pulls 100 pages of background material to, quote-unquote, help the model, you are paying a massive tax on 99 pages of completely irrelevant information. And worse, as the analysis points out, you have layers of hidden consumption.
Right, the invisible tolls. The source actually mentions cached tokens and system prompts.
Yeah, consider the system prompt. This is the set of behavioral instructions running invisibly behind the scenes of an application. It's the stuff that says, you are a helpful corporate assistant. You must always answer in French. You must never offer medical advice.
The guardrails.
Exactly. The user never sees this text. But the API sends that system prompt to the language model with every single query. So if a developer writes a bloated, sprawling 500-word system prompt, your company is paying to process those 500 words thousands of times a day, every single time any user interacts with the tool.
So you have a situation where an employee types a 5-word question like, what is the guest Wi-Fi password?
Yes.
But behind the scenes, the application is bundling those 5 words with a massive invisible system prompt, plus injecting 10 pages of company IT manuals just in case. So the finance team thinks they're paying for a 5-word interaction, but the invoice reflects a 10,000 token transaction.
And this brings us to the crux of the crisis, the absolute lack of visibility. In most corporate deployments today, teams have zero visibility into their per workflow or per user token spend.
Nothing. A black box.
A total black box. The engineering team builds a feature, the workforce adopts it enthusiastically, and the finance department is completely flying blind until the end of the month when the cloud provider debits the corporate account.
Which is terrifying. I mean, if you were a business leader, this microscopic unit of trade explains why your company's incredible, highly publicized internal AI tool might suddenly get shut down on a random Tuesday.
Yep, that happens all the time.
It is not because the tool hallucinated or because it wasn't useful to the staff. It is because it triggered a massive unbudgeted token hemorrhage. And the CFO simply had to pull the plug to stop the bleeding.
It is entirely a survival issue for these enterprise projects. I mean, if the economics don't work, the technology just doesn't matter. And this harsh reality is perfectly articulated in the source material by someone who processes an unfathomable amount of corporate data.
Aaron Levie.
Yes, Aaron Levie, the CEO of Box.
I found his inclusion in this analysis so compelling because if anyone understands the danger of unpredictable scaling, it's the executive running a cloud content management platform that houses millions upon millions of business documents for Fortune 500 companies.
Absolutely.
The article frames his commentary as a massive wake-up call regarding the actual economics of enterprise AI.
Levie has been a critical, really grounding voice in this space. While much of the tech sector is caught up in a features arms race, announcing new modalities, faster generation speeds, better reasoning benchmarks.
It's on the object syndrome.
Exactly. Levie has consistently steered the conversation towards sustainability. His fundamental premise is that companies are attempting to build AI-powered workflows that are just destined to collapse under their own cost weight.
And his core diagnosis is fascinating. He argues that enterprise leaders are treating AI today the exact same way they treated early cloud computing 10 or 15 years ago.
Yes.
They view it as this infinite elastic resource, and they assume they can just deploy it wildly across the company and figure out the unit economics later.
Which is a deeply flawed analogy, as he points out. With early cloud storage or basic compute instances, that strategy sort of worked.
Right.
The costs were relatively static, and you could easily audit your server usage. But token costs do not behave like server racks.
Here is where I have to play devil's advocate, though.
Sure.
Because if we look back at, say, 2012, Everyone was absolutely panicking about cloud costs. Companies were leaving massive server instances running over the weekend and getting hit with giant AWS bills.
Ver-
But eventually, the crisis subsided. We built better dashboards, sure, but more importantly, compute cost just inherently went down over time.
Yeah.
Moore's Law, better silicon, massive data center efficiency. So why is AI fundamentally different? Shouldn't the cost of processing a token naturally approach zero over the next few years as these models just get more efficient? Why panic now?
It's the most common counterargument,
Yeah.
but it fundamentally misunderstands what drives the cost. Yes, the raw computational cost of running a transformer model on a GPU will likely trend downward.
Okay.
But AI token consumption is not static like a gigabyte of storage. It is inherently tied to human behavior and human workflow architecture.
Human behavior. We are the unpredictable variable in the equation.
Precisely. If you buy a terabyte of cloud storage, it sits there. It does exactly what you expect. But a token budget fluctuates wildly based on how wordy your employees are,
Oh, man.
how elegantly your engineers design their background prompts, and how intelligently your data retrieval pipelines are built. Human behavior is notoriously difficult to standardize.
That is so true.
So even if the baseline price of a token drops by 50% next year, if your unstructured human users suddenly start demanding the AI process 10 times as much unnecessary text because they've gotten lazy with their queries,
Your overall bill still explodes.
your bill still explodes.
That makes total sense. You can't out-innovate fundamentally wasteful behavior. Levy actually points to 4 specific areas where this behavioral and architectural waste causes enterprise token spend to just spiral out of control. Let's break those down because they are incredibly relatable to anyone working in tech right now. The first one he identifies is the overcrowded context window we touched on earlier.
Yeah, this is the most prevalent architectural sin in the enterprise right now.
Yeah.
The source describes teams that need an AI model to extract a single specific data point from a massive legal contract, say the termination clause.
Right.
Instead of building a system that isolates and extracts just the termination section, the engineers build a pipeline that takes the entire 100-page PDF, converts it to text, and dumps the whole thing into the prompt.
Going back to our taxi cab, you are basically forcing the driver to listen to a 100-page audiobook just so you can ask for the address of the coffee shop mentioned on page 42.
Yes.
You are paying the toll on 99 pages of completely irrelevant legal boilerplate.
Exactly. The second area Levie highlights is redundant API calls. This is a symptom of fragmented, poorly planned workflow architecture.
How does that look in practice?
Well, you will see systems that are engineered to make multiple separate calls to a language model to accomplish a sequence of tasks. So maybe extracting a name, then a second call to classify the sentiment, then a third call to summarize the text.
I see.
When a single, well-structured, complex prompt could have instructed the model to return all 3 of those outputs in one single transaction. Every redundant call means paying that hidden system prompt tax over and over and over again.
And that leads directly into his third area of waste, which is the absolute lack of prompt governance.
This is where the human behavioral element really shines through. You have different teams or even different developers within the exact same team writing wildly different instructions for the exact same routine task.
Right.
One developer writes a tight, highly efficient, heavily constrained prompt. Another developer writes a sprawling, conversational, almost philosophical essay instructing the AI on how to summarize an email.
Right.
The result is that the company experiences wildly different token counts and therefore wildly different costs to achieve the exact same output.
I've actually seen this. People typing into enterprise chatbots saying, hello, good morning, please, if it wouldn't be too much trouble, could you kindly summarize this meeting transcript for me? Thank you so much in advance.
Yes.
You are literally paying corporate funds for those pleasantries.
You are paying a financial penalty for anthropomorphizing the machine. The AI does not require politeness to function. It requires rigid, clear logic. And the fourth area Levie points out, which is arguably the most financially devastating, is model mismatching.
This is a huge one. This happens when teams default to using the frontier models, the absolute most powerful, complex, and expensive models on the market, like a GPT-4 Turbo or a Claude 3 Opus.
Yep.
And they use them for incredibly mundane, simple tasks.
It is the equivalent of using a quantum supercomputer to calculate a 20% tip on a diner receipt. Does the supercomputer get the math right? Of course it does. But a basic calculator could have done it for a fraction of the cost.
And what makes this so critical is that Box, as a company, sits directly at the intersection of enterprise content and AI analysis. When they process millions of documents through their AI workflows, the financial cost of doing that inefficiently doesn't just result in a mildly annoying bill.
Yeah.
It compounds exponentially into millions of dollars of loss margin. For them and for the enterprise customers they advise, solving this isn't a theoretical exercise for an engineering blog. It is a fundamental survival mechanism.
Which is why the analysis points to the emergence of specialized advisory frameworks. The source actually mentions Constellation Research, which is actively building structured advisory protocols to help organizations navigate this exact transition.
Really?
Yeah, they recognize that you cannot simply mandate cost reductions. You have to fundamentally move the organization from a mindset of unconstrained experimentation into a highly disciplined, cost-aware deployment model.
And that transition requires deep technical intervention. If Aaron Levie has correctly diagnosed the disease, that unpredictable costs are rooted in sloppy human behavior and unoptimized workflow architecture,
Yeah.
then the cure must be rooted in specific, enforceable engineering practices. We have to change the architecture to govern the behavior. The source material outlines a comprehensive methodology for this, focusing on 4 highly specific engineering fixes.
These fixes represent the crucial bridge between corporate finance and software engineering. They are the mechanisms that transform a hemorrhage into a sustainable system. But before we get into the technical weeds, we really have to establish the overarching philosophy of this approach.
Which is?
Getting control of your AI token spend is fundamentally not about using AI less. It was about using it with architectural intelligence.
I absolutely love that framing. Don't restrict the capability, engineer the efficiency.
Exactly.
So let's explore the first of these engineering fixes. It starts with the most basic rule of management. You cannot manage what you cannot see. The first technical mandate is establishing absolute token visibility and monitoring.
It is the foundational layer without which nothing else works.
Yeah.
The article makes it clear that before you can optimize a single prompt, you have to instrument your entire AI infrastructure so that token consumption is tracked relentlessly at every possible level.
By the department.
By the specific application, by the workflow, and down to the individual user.
The source specifically names the specialized tools built for this, right? It mentions platforms like Langsmith, Helicone, and PromptLayer. But how do these actually work in practice? If I'm an engineering lead, how do these tools suddenly give me a dashboard of my spending?
If we look at the mechanics, these tools essentially act as an intelligent proxy layer. So in a typical unoptimized setup, your company's application sends a request directly to the model provider, say OpenAI or Anthropic, and the provider sends the answer back.
Right.
The only data you get is a bulk invoice at the end of the month. But tools like Helicone sit in the middle of that transaction. Your application sends the request to the proxy. The proxy intercepts it, inspects the payload, counts the exact number of tokens in the prompt, and tags it with metadata.
Like who set it?
Like which user sent it and which internal project it belongs to. And then it forwards it to the model provider.
So it's essentially installing a highly detailed, itemized toll booth on your own network before the traffic ever reaches the highway.
Precisely. And the return path is monitored the exact same way. The proxy counts the output tokens generated by the model before passing the answer back to your user. Suddenly, instead of a mystery bill, your finance and engineering teams have real-time granular telemetry.
That's huge.
You can look at a dashboard and say, the marketing department's new copywriting tool consumed 4 million tokens yesterday, but the legal department's contract analyzer only used 200,000.
Without that instrumentation, cost optimization is literally just guesswork. You are looking at a massive bleeding wound and trying to put a Band-Aid on a shadow.
Exactly.
But once you have that proxy layer installed and you can actually see the traffic, you can start applying the second engineering fix. And here's where it gets really interesting. We move into treating prompt engineering as a financial discipline.
If we connect this to the bigger picture of how the industry has evolved, prompt engineering was initially viewed as a quirky, almost linguistic art form.
Oh yeah, people called themselves AI whisperers.
Right. It was all about coaxing better performance out of the model, figuring out the magic words to stop it from hallucinating or formatting its output incorrectly. But what this analysis reveals is a massive paradigm shift. Prompt engineering is now a literal cost engineering role. The syntax, structure, and length of a prompt mathematically dictate its financial cost.
The source provides a devastating concrete example of this. It compares 2 different approaches to the exact same task. Asking an AI to generate a summary.
Yes.
An unoptimized, poorly structured prompt might require sending 3,000 tokens of background context and instructions, and it might return a sprawling 800 token output. So you are billed for 3,800 tokens for one single action.
But the analysis demonstrates that a rigorously engineered version of that exact same task using tight constraints, XML tagging for data structure, and explicit length limits might consume only 400 tokens in total input and output.
Think about the massive scale of that difference. You are dropping from 3,800 tokens down to 400. That is close to a 90% reduction in cost.
Huge.
And you are getting the exact same functional business value out of the model. Now, take that 90% savings and multiply it across 50,000 interactions a day across a global enterprise.
That's staggering.
That is the razor-thin margin between an AI initiative that is celebrated as a massive success and one that is quietly killed by the finance department.
The source highlights an insight here that I think should be printed and taped to the monitor of every developer working with language models. It states, quote, "Every unnecessary sentence in a system prompt is a tax on every single API call that uses it."
A literal tax. We talked about system prompts earlier, but let's really drill into the financial mathematics of this.
Let's do it.
If I'm an engineer, my instinct is to make the system prompt as comprehensive as possible. I might write a 500-word manifesto instructing the AI on corporate brand voice, compliance rules, and formatting preferences, just to be absolutely safe.
And every single time any employee in the company uses that tool to ask a 5-word question, those 500 words are processed and billed by the API. If your application handles 10,000 queries a day, you are paying to process 5 million words of identical static instructions every single day.
It is a hidden, recurring surcharge on every single transaction.
Yes.
If a cost-aware prompt engineer can audit that system prompt, strip out the conversational filler, condense the rules into tight bullet points, and reduce it from 500 words down to 50 words while maintaining the exact same behavioral guardrails, they have just unilaterally eliminated a massive financial drain.
They have permanently altered the unit economics of the application.
Yeah.
And this transitions perfectly into the third engineering fix, intelligent model routing.
Right.
We used the diner tip analogy earlier, but let's explore how you actually engineer this in practice, because this is where the real architectural sophistication comes in.
Right. The goal is to ensure that not every task gets sent to your most powerful, most expensive model. A practical, financially viable AI architecture dynamically routes incoming tasks to the appropriate model tier based on the complexity of the request.
The source outlines the categories of tasks that absolutely do not require frontier models. It highlights classification tasks. So like reading an incoming customer email and deciding if it belongs in the billing issue bucket or the technical support bucket.
Simple sorting.
Exactly. Or it mentions extracting specific entities from structured text or generating very short, templated responses.
If you need an AI to parse an email and tell you if the customer sounds angry or happy, you do not need GPT-4 Turbo.
You absolutely do not. The article stresses that these types of narrow, well-defined tasks can run incredibly effectively on smaller, highly optimized models, like GPT 3.5 Turbo or Claude 3 Haiku.
Which is so much cheaper.
And the financial delta is staggering. These smaller models operate at a tiny fraction of the cost and often with significantly lower latency than the massive frontier models.
But how do you actually build that? If I have an enterprise application, how does the system know which model to use? Do I just make the human user choose from a drop-down menu? Because knowing human nature, they will just click the most expensive one every single time.
Oh, without a doubt.
Yeah.
No, you cannot rely on the end user to make cost-benefit analyses on the fly. You build an intelligent routing layer into the application architecture.
Okay.
There are a few ways engineers execute this. One method is using an incredibly cheap, fast model, simply as a classifier. The cheap model reads the user's prompt, determines if it requires complex reasoning or simple extraction, and then forwards the prompt to either the frontier model or the economy model.
So you spend a fraction of a penny to let a small AI act as the traffic cop, directing the query to the right toll booth.
Exactly. Another highly efficient method is semantic routing. Engineers use vector embeddings, which are basically mathematical representations of the prompt's intent. They use those to instantly match the user's request against a predefined database of task types. If the embedding suggests a routine classification task, the router instantly sends it to Claude 3 Haiku. If the embedding suggests a request to generate novel, complex code, It routes it to GPT-4.
That is so smart.
Building and tuning that routing logic is one of the highest leverage investments an engineering team can make. It automates financial discipline.
Which brings us to the fourth engineering fix. And I want to spend some serious time unpacking this because while it sounds deeply technical, it is the battleground where the most massive token bloat happens. The fourth fix is R optimization.
Yes.
RDRI stands for Retrieval Augmented Generation. For our listeners who might just be end users of these tools, let's clearly define what R is doing behind the scenes before we talk about optimizing it.
Retrieval augmented generation is the foundational architecture for almost all enterprise AI applications. Language models are trained on public data. They do not inherently know your company's proprietary secrets, your internal HR policies, or your private financial data. RAG is the bridge. When a user asks a question, the RAG system first performs a search across your company's private databases, retrieves the documents that seem relevant to the question, and then invisibly pastes those documents into the prompt alongside the user's question.
Okay.
It essentially says to the model, read these private documents and use them to answer the user.
Okay, so if I ask my company's internal AI, what is our policy on remote work and travel reimbursement? The model doesn't just guess.
Yeah.
The RAG pipeline intercepts my question, searches our corporate intranet, finds the employee handbook, grabs the paragraphs about remote work, shoves them into the prompt, and says, based on this retrieved text, answer the user.
That is the exact mechanism. It grounds the AI in your factual reality. But as the article definitively points out, RAG pipelines are the single most common source of catastrophic token bloat in the modern enterprise.
Why? If the system is just grabbing the relevant paragraphs to help the model, shouldn't that be a highly efficient way to get accurate answers?
It comes down to a pervasive false temptation in engineering design. When developers build the retrieval part of the pipeline, they face a challenge. Search algorithms aren't perfect.
True.
If the system isn't entirely confident which specific paragraph holds the exact answer, the overwhelming temptation is to broaden the net. The engineer thinks, well, to ensure the AI is everything it could possibly need to give a good answer, I'll just configure the system to retrieve the top 20 most relevant pages and throw them all into the context window.
So instead of surgically extracting the 2 paragraphs about travel reimbursement, the system panics and dumps the entire 50-page employee handbook into the prompt just to cover its bases.
Yes. And as the source material explicitly warns, more context equals more tokens. You are paying the premium API toll on all 50 pages every single time a user asks a simple question.
That is brutal.
But the financial cost is only half the tragedy here. The article notes that poorly tuned retrieval, which injects massive amounts of irrelevant text, doesn't just hurt your budget. It actively degrades the accuracy of the AI.
Wait, I really want to push back on this.
Yeah.
If I am a corporate lawyer using a RAG system to interrogate a massive merger and acquisition repository, I do not care about a $5 API fee. I care about missing a crucial liability clause buried in an addendum. Isn't restricting the context incredibly dangerous? Shouldn't more information logically make the AI smarter and more comprehensive?
It is a highly intuitive assumption, but the data proves it wrong. More information only makes the model smarter if the information is highly relevant. If you flood the context window with irrelevant noise, you are actually inducing hallucinations.
Really? How does extra text cause a hallucination?
Because language models operate on attention mechanisms. They have to decide which words in the prompt are most important to the user's question.
Okay.
If you force the model to sift through 20 pages of loosely related HR jargon, outdated policies, and irrelevant boilerplate just to find the one sentence about travel reimbursement, you drastically increase the mathematical probability that the model's attention drifts.
Oh, I see.
It might pull a rule from a 2018 policy that happened to be in the retrieved chunk, or hallucinate a connection between 2 completely unrelated clauses. Irrelevant context dilutes the model's focus.
So by trying to be too safe and providing too much data, you confuse the machine and pay a massive premium to do so. So how do we fix it? The source mentions optimizing chunk size, retrieval precision, and re-ranking logic.
Let's decode those.
Yeah, chunk size is literal, right? How big of a piece of text you chop your documents into before searching them.
Exactly. If you chunk your database by chapter, you are retrieving whole chapters. If you chunk it by paragraph, you retrieve paragraphs. Optimizing chunk size means finding the sweet spot where the retrieved text contains the complete thought, but no extraneous fluff.
And what about re-ranking logic? This sounds like the secret sauce.
It is. When a standard RBAC system searches your database, it might find 50 chunks of text that share keywords with the user's query. Re-ranking introduces a specialized secondary AI model, often called a cross-encoder. Its sole job is to evaluate those 50 chunks and strictly score how well they actually answer the specific question.
Eh.
It acts as a ruthless editor. It takes the 50 potential chunks, scores them, throws out the 45 that are only tangentially related, and only passes the top 5 most highly concentrated, relevant chunks to the final language model.
So the re-ranker is the bouncer at the club, making sure only the absolute most necessary context gets through the door and into the expensive context window.
That's exactly what it is.
And the payoff for implementing this level of engineering discipline is massive. The article states that optimizing these R-Yang elements can cut RG-related token costs by 40 to 60%.
It cuts costs by up to 60%, and crucially, because you have removed the distracting noise, the final output quality actually improves. It is the rare engineering win-win. You pay significantly less money to get a significantly more accurate and reliable answer.
Okay, so we have the 4 technical fixes clearly defined: establishing visibility, treating prompt engineering as finance, implementing model routing, and rigorously tuning RGAG optimization. But here's the reality check. Engineering does not happen in a vacuum. A couple of brilliant, cost-conscious developers can implement these on their own local projects. But how do business leaders actually force these practices across an entire global enterprise? If you just mandate be cheaper, you risk stifling innovation and bringing adoption to a grinding halt.
That is the operational chasm that most companies are falling into right now. The source argues convincingly that enterprise AI programs generally do not fail because the underlying technology is flawed. They fail because the organization failed to build an operational framework around the technology.
Right.
Managing token spend has to be elevated from a localized engineering headache to a centralized leadership mandate.
It is the shift from guesswork to governance. And the article lays out a highly practical 5-step operational framework that leaders can implement immediately to regain control.
Wow.
Let's look at how this actually rolls out in a corporate environment. Step 1 is establishing a token spend baseline.
You cannot measure the success of an optimization if you do not know the magnitude of the waste. The framework mandates pulling 30 days of raw API usage data across every active AI integration in the company. Using the visibility tools we discussed, leaders must map that token consumption down to the workflow, the specific team, and the models they are using. That baseline becomes the immutable benchmark against which every future engineering decision is judged.
Once you have the map of where the money is burning, you move to the second operational step, setting token budgets by use case. And this is where the concept of return on investment finally enters the AI conversation.
This is a critical maturation point. Not all AI use cases are created equal, and they should not be funded equally. The source contrasts 2 very distinct scenarios to illustrate this point.
Okay.
First, imagine a highly specialized legal document review workflow. If that RA pipeline is analyzing complex contracts and provably saving 10 hours of highly paid external attorney time every single week, it is generating massive quantifiable business value.
The ROI on that tool is undeniable. Therefore, it logically deserves a massive token budget. It completely justifies the use of a premium frontier model like Claude 3 Opus or GPT-4 because the financial return dwarfs the API cost.
That's exactly. The budget matches the value. Now, contrast that legal tool with an internal HR chatbot built by a well-meaning engineering team,
Okay.
designed to answer basic employee FAQs like, how do I reset my password? Or what days are standard holidays?
Yeah.
That chatbot is undoubtedly convenient. It might save a few emails, but it is not generating the same hard, direct financial ROI as the legal tool.
So if the engineer who built that HR bot was sloppy and wired it directly to GPT-4 Turbo and configured the RAG to pull the entire 50-page employee handbook into the context window for every single question,
Yep.
you are suddenly paying 15 cents a query just to tell an employee that Thanksgiving is a holiday. Multiply that by 5,000 employees asking questions, and that convenience tool has become a financial liability.
Which is why the operational framework demands that leaders assign strict, enforced token budgets based on the generated business value, not based on whatever the technical team wants to experiment with. The HR bot should be rigidly capped, routed to an economy model, and forced into high optimization.
This flows perfectly into the third operational step, creating prompt standards and libraries. We discussed earlier how different teams will write wildly different, often bloated prompts for the exact same task. This step is about killing that inefficiency through centralization.
The massive danger in a large enterprise is teams constantly reinventing the wheel in isolation. If 5 different product teams need an AI function to summarize customer feedback, you do not want 5 different developers writing 5 different system prompts.
Right.
You are mathematically guaranteed that some of those developers will accidentally build sprawling, expensive prompts.
A centrally governed prompt library solves this entirely. Your best prompt engineer designs the perfect, hyper-concise, low-token feedback summary prompt one single time. They lock it into the central library, and every team in the company is required to pull from that repository. As the article states, centralizing and standardizing your prompts is one of the fastest, lowest friction ways to instantly eliminate token waste across an organization.
It is standardization serving the ultimate goal of financial efficiency.
And then we reach the fourth operational step, which is the governance side of model routing, implementing model tiering policies. We know how routing works technically, but this is about the human policy. You have to explicitly define, document, and enforce which model tier is approved for which categories of enterprise tasks.
Because if you fail to explicitly document and enforce these policies, human nature will inevitably take over.
Of course it will.
Without a policy, engineers and users will always default to using the most famous, most powerful frontier model out of sheer habit, or just out of a desire for absolute certainty that the model can handle the task.
I really want to ask you, the listener, to evaluate your own workplace right now. If your company is rolling out AI tools, are your teams just using the most expensive frontier model simply because it's the only one they know the name of?
It's so common.
Are they hammering GPT-4 for everything just because it's the famous brand? If they are, you are bleeding cash on simple sorting and extraction tasks that a model like Claude 3 Haiku is perfectly designed to execute for pennies.
It is a pervasive trap. To escape it, leadership must institute documented policies that state explicitly: for internal data extraction and classification, you are mandated to use Tier 3 economy models. For client-facing generation or complex multi-step reasoning, you must submit a request to be approved for Tier 1 frontier models.
And finally, the framework concludes with step 5, review and optimize monthly. Because the one constant in the AI landscape right now is violent, rapid change.
The environment is entirely dynamic. Token costs fluctuate, new models with entirely different pricing structures are released monthly, and user behavior shifts as they become more comfortable with the tools.
Right.
The framework dictates a rigorous monthly review of the spend data. Leaders must compare the current month's token consumption against the baseline, identify new areas of bloat, and continuously adjust their routing logic, their prompt templates, and their RG configurations. It is not a one-time fix. It is a continuous, relentless process of financial tuning.
So we have explored the theory. We have internalized the urgent warnings from executives like Aaron Levie. We have mapped out the specific engineering architectures, and we have outlined the operational governance framework.
Yes.
But frameworks are ultimately just theories until you look at the receipts. Let's look at the hard, undeniable numbers. The source article provides a highly detailed data table projecting what actually happens to the bottom line when these engineering practices are combined at enterprise scale. And the mathematical reality is staggering.
The projection is incredibly illuminating. The table models a scenario of 50,000 daily API calls. To provide context, for a mid to large enterprise running integrated AI assistance, customer support triaging, and internal document analysis across a workforce, 50,000 queries a day is a highly realistic, arguably conservative volume.
Right. So we are looking at 50,000 daily interactions. The first row of the data table models the unoptimized deployment. This represents the baseline flying blind scenario we see in so many companies today.
Yeah.
They are using a frontier model like GPT-4 Turbo for absolutely everything. And because they haven't optimized their system prompts or tuned their gamma ray retrieval pipelines, they are averaging 4,200 tokens per single API call.
4,200 tokens per call. When you extrapolate that out, 50,000 calls a day multiplied by 30 days at 4,200 tokens a transaction. The estimated monthly cost, based on the publicly available model pricing structures at the time of the analysis, comes to roughly $63,000.
$63,000 a month. That is over $750,000 a year, entirely consumed by unoptimized token spend.
And remember the tragedy of the unoptimized state.
Oh.
A massive percentage of that 4,200 token average is pure bloat.
Just waste.
It is the cost of processing 50 pages of irrelevant RAG context. It is the cost of processing overly polite conversational system prompts. It is literally wasted space.
Okay, so then we move to the second row of the table. Optimized with routing. This is the scenario where the company applies just one of our engineering fixes.
Aha.
They haven't fixed the prompts yet, and their RAG is still messy, but they stop using the frontier model for everything.
Right.
They implement an intelligent router that analyzes the 50,000 daily calls and sends the simple, repetitive tasks to a cheaper model.
And look at the immediate financial impact. By simply implementing a mixed-tier routing strategy, their average number of tokens processed by the expensive frontier models drops drastically. Their effective blended cost drops, and their estimated monthly bill plummets from $63,000 down to roughly $18,000.
That is a $45,000 a month savings simply by installing a digital traffic cop to ensure you aren't using a supercomputer to do basic arithmetic.
Exactly.
But the analysis doesn't stop there. The third row represents the ultimate goal, fully optimized plus OG tuning.
This is the scenario where the organization enforces the entire framework. They are utilizing mixed-tier routing, aggressively offloading tasks to highly efficient models like Claude 3 Haiku. They have governed their prompt libraries to ruthlessly eliminate the system prompt tax.
Yes.
And crucially, they have implemented cross-encoder re-ranking in their RK pipelines, so they are only retrieving the exact, highly concentrated context needed to answer the user.
By combining all of those engineering disciplines, the average token consumption per call plummets from 4,200 all the way down to just 950 tokens. And the estimated monthly invoice, it drops to roughly $7,500.
From $63,000 down to $7,500. I want to pause and emphasize the sheer magnitude of this reduction. We are talking about nearly an order of magnitude difference in cost.
It's unbelievable.
And this is the most critical detail to absorb. This dramatic reduction is achieved while supporting the exact same volume of daily usage.
That is the part that completely reorients how you view this technology. They are still successfully processing 50,000 daily API calls. The workforce isn't using the AI any less. The company hasn't throttled productivity. They are simply executing the exact same workload with absolute surgical architectural efficiency.
That data table is the definitive financial argument for why leaders must take token budgeting seriously right now. It perfectly illustrates the cost discipline that executives like Aaron Levie are demanding enterprises adopt.
Before it's too late.
Exactly. Before their experimental AI programs scale to the point where structural optimization becomes a political and technical nightmare. Trying to retrofit these rigorous practices onto a massive, sprawling, unoptimized global system a year from now will be exponentially more difficult than building the discipline today.
Which perfectly sets up the final, overarching strategic shift discussed in the analysis. The article posits a profound conclusion. The companies that will ultimately win the AI race over the next 5 years are not necessarily the ones with the flashiest, most aggressive, wide-open deployment strategies.
No, the long-term winners will be the organizations that figure out how to operationalize these programs sustainably. The victors are the companies that possess the structural discipline to ensure that the actual business value generated by their AI models consistently, provably exceeds the computational cost of generating it.
It demands a fundamental mental shift at the highest echelons of leadership. AI token budgeting is no longer an obscure, deeply technical detail that the C-suite can just delegate to a mid-level engineering manager and ignore.
And this raises an important question for any business leader. How do companies align AI token budgeting with traditional headcount or software licensing budgets? AI token budgeting must be elevated and treated as a core financial discipline.
Right.
It belongs in the exact same agenda, in the exact same high-level conversations as your cloud infrastructure cost management, your multi-year enterprise software licensing renewals, and your workforce headcount planning.
The inputs of the conversation might sound highly technical, debating document chunk sizes, cross-encoder re-ranking logic, and vector embeddings. But the final decisions and the impacts on margin are purely strategic.
The analysis concludes with a powerful reality check. The leaders who approach token budgets with the exact same seriousness, rigor, and auditing standards that they apply to human headcount budgets are the ones who will be able to scale their AI initiatives confidently, predictably, and profitably into the future.
So what does this all mean? When you strip away the API jargon and the architectural diagrams, AI token budgeting is ultimately a rigorous financial discipline, cleverly disguised as a technical detail.
Very well said.
It is the stark realization that in the age of generative AI, your words, quite literally and mathematically, equal money.
The industry has officially transitioned. We have graduated from the breathless excitement of exploring what the technology is capable of doing into the mature, necessary, and occasionally painful phase of figuring out how to structurally pay for it without destroying our profit margins.
We have covered a massive amount of incredibly dense ground today. We started by mapping out the hidden hemorrhage, understanding that every single token, every roughly 4 characters of input and output, represents a microscopic but compounding financial transaction.
Yep.
We analyzed Aaron Levie's urgent warnings regarding how unconstrained human behavior, our innate tendency to dump massive amounts of irrelevant information into prompts, fundamentally breaks AI budgets because token consumption does not scale linearly like old cloud storage.
We then deeply explored the specific architectural engineering fixes required to solve this. You cannot simply hope for lower bills. You have to build them. That means establishing unblinking visibility using proxy tools like Langsmith and Helicone. It means elevating prompt engineering from a linguistic trick to a literal cost-saving measure, ruthlessly stripping out the hidden system taxes.
It means building intelligent model routing layers, ensuring you aren't firing up a frontier supercomputer for a simple text sorting task. And it means locking down your RAG pipelines with re-ranking logic, so you aren't paying a premium to feed the AI pages of irrelevant noise just to extract a single sentence.
And finally, it requires the commitment to build an operational framework to govern all of this capability, establishing baseline metrics, assigning token budgets based strictly on hard ROI, and continuously auditing the data, which, as the numbers definitively proved, can take a $63,000 monthly liability and engineer it down to $7,500 without dropping a single query.
It is an incredible architectural transformation. And as we wrap up this deep dive, the ultimate takeaway is deeply personal. Whether you are a senior developer architecting the system prompt for a global application, a department manager approving a new AI rollout, or just an everyday employee interacting with a company chatbot, you must understand that you are interacting with a finite, highly strategic, highly variable resource.
You are. Every single prompt you write is a micro investment of corporate funds. It carries a real-time cost, and it needs to deliver a proportional return.
Which leaves me with a final, slightly provocative thought I want you to mull over as you head back to work. It builds entirely on what the analysis exposed about token costs being fundamentally driven by human behavior and prompt design.
Okay, let's hear it.
If every unnecessary word, every polite pleasantry, every sprawling sentence in a system prompt acts as a literal financial tax on the company's bottom line, will the near future of our jobs require us to become hyper-efficient, mathematically precise communicators?
It is a fascinating organizational implication.
Right. As companies are forced to build these increasingly strict token budgets, and as tools like Helicone provide dashboards showing exactly which employees are burning the most cash on bloated queries, will your core value as an employee eventually be measured by your quote-unquote token efficiency?
Oh, wow.
Will we soon be evaluated on how cheaply, rigidly, and concisely we can coax the exact right answers out of the machine?
It certainly provides a deeply financial new meaning to the phrase, choose your words carefully.
It really does.
Yeah.
Because in the unyielding economics of enterprise AI, those words are literally hitting the bottom line with every keystroke. Thank you so much for joining us on this deep dive into the architecture of AI cost reduction. Keep questioning the systems around you, keep looking beneath the hood to see how the hidden architecture works, and seriously, watch your word count.